This video is going to cover the installation of LED string lighting underneath the railing on a deck. It can be applied to any outdoor railing, and we're going to go through the thought process you'll need to look at in taking on such a project. This particular project entailed a railing that was approximately 31 feet in length. To accommodate that, we're going to illuminate 19 feet on one side and 12 feet on the other, using home-run power cables back to the power source. This deck was built in approximately 1990. It originally had some Malibu lights along the front edge, and to accommodate that, there is an outlet and a switch to control that outlet outside. The other consideration was we could install the power on the inside in the basement. This install will use the outdoor electric position. The deck sits above the driveway, so you're looking up at the deck from the driveway. So it's important that when we install the lights, we're not looking directly at the lights, but the illumination the lights provide. So to do that, we were going to install the lights directly under the handrail. Unfortunately, some of the handrails were offset, not allowing the lights to be installed because there wasn't enough room. So the compromise was to install the lights on the bottom of the baluster support. The balusters are vertical boards underneath the railing. This is fine. It was not as high as the railing, but generated the same effect and worked fine. To control the lights, in addition to the on-off switch for the outlet, I wanted to make sure they could turn on automatically at dusk, so I put in a daylight sensor. I also wanted to be able to dim them when it was necessary to have a little less light, so I decided to install a dimmer. One option was to install a Wi-Fi controller, but in this particular case, I needed this to be very non-technical and always reliable. The dimmer I decided to put as close as I could to the door, so it's the front corner right above where the power supply was installed. So that worked out well because all the electronics were near each other. To accommodate the power needed for the other side of the deck, I ran a power wire directly from the dimmer to a junction box at the far side of the deck, which we run up to service the lights under the rail, and the lights we decided to install under a small part of the house eave to help illuminate the grill on that side of the deck. We chose a 12-volt warm white LED strip that we wanted to use. That's water resistant, meaning it has the silicone on top. For longevity, you want to keep the water off these as much as possible. I decided to mount them inside an aluminum tray. We found in the basement some old shelf supports that are very much like what you buy in the store, which is a C-channel piece of aluminum. I'm using 10mm light, so if I was buying this aluminum at the store, I'd be using the 1/2-inch C-channel. Now, you could also possibly use a LED light channel. Unfortunately, they're pretty wide and probably wouldn't fit under a lot of railings. It depends on how much space you have. To mount the aluminum, we drilled holes in the aluminum, countersunk them, and then put some small screws in to put it on the bottom of the ballast support. To minimize the amount of soldering done outside, we soldered short wires on the end of the LED strips, put the LED strips in the aluminum tray, and then laid down a bead of silicone on each side of the LED strip to prevent it from falling out. The connections are done using blue gel caps. These are nice because they're very small and narrow and could be pushed up in the tray. They also contain a small amount of gel to help prevent corrosion. They do have openings on either end, so to prevent water from getting in, we did go ahead and silicone those at the end, at the top and the bottom, to minimize the amount of water that can get into the connection. To keep the installation nice and clean, we decided to drill holes through the 4x4s, allowing the wires from one section of light to connect to the other section through a hole in the 4x4 uprights. To keep the power supply and distribution wires dry, I mounted an old cake pan lid at an angle underneath the deck, so the water running through the deck wouldn't run over all the wiring. Once the power supply was installed, I put a couple pieces of aluminum up there to support all the wires so I could tuck those in. The first place the power needed to go was to the daylight sensor, because that was going to be the first in line to turn things on and off. The daylight sensor would then go to the dimmer. The dimmer I installed in an outdoor box that I had salvaged from a garbage pile and already had a piece of pipe on the bottom. I did have to notch the switch a little bit at the brackets to make it fit. Other than that, it worked perfectly. After the dimmer, we went ahead and we wired to the first set of lights that were on the near side. And then we put another wire off the dimmer to the junction box, and then from the junction box we wired the light that went under the eave to support the grill and to the railings on the far side. So did I need the junction box? At 31 feet, kind of pushing the limit. I needed this to be a very reliable install. If I tried to daisy chain the wires all the way across, it's possible that I would have had some dimness or flickering at the far end. These deck lights are in the northeast, and they've been running for 7 months now. So they have to be able to accommodate the heat of the summer and the cool of the winter. And you can see right now that they're still out there, and they're managed to make it through all the snow. They illuminate every night. When you're putting outdoor connections in, you want to do a couple things. First is when you run the wires, you want to have a little dip in the wire before you get to a fixture or an end. Water tends to run along wires and downhill. Even if you caulk it and everything, you don't want the water challenging you to see if it can run into your electronic. Because you're sealing everything, it does make it a little hard to diagnose things because you can't just take the connection off and do it. The nice thing about this power supply is it does have some twist-on connectors right off the power supply, so if we needed to do a test of the power supply, we could do it right at that point. If you had sprinklers, that's something else to consider. Sprinklers spray upward, so if you're designing for blowing water or gravity water, sprinklers can totally defeat that by going upward. So I use 12 volt, you could use 24 volt. 24 volt uses half the amperage per distance. It's the same exact wiring as the 12 volt. The most 12 volt fixtures like dimmers and electronics will work with 24 volt, but you must purchase a 24 volt power supply, and you must purchase 24 volt LED light strings, which might limit your selection some. Another option is to use 110 volt or 220 volt AC strings. Now those, you're a little limited on cutting them. You can only cut them usually every half meter if you can cut them at all, which means you need to control your spacing. The wires in between, if you're using color, you can have more wires, but you're generally going to need some proprietary wires and connectors, and figure out how to make sure you know how to connect all those. Installing power outdoors is one of the biggest challenges. Buying a dry box can be pretty expensive. If you do have an option of going into a cellar or indoor through an eave, it's sometimes a good option because you can hang the power supply in a dry environment and run the power outside. And that's a nice advantage of DC. You can do that kind of freely. AC, you have to be very compliant with local safety and governance. Now, I did put a mechanical controller in here. You could use a Wi-Fi controller and use it from your phone or talking device like an Alexa or Google.
Keep your lights on.
Now, if you did that, you do have to make sure you have sufficient Wi-Fi coverage to the controller wherever it's located to make sure that it's always on and available. And you also want to consider that you're going to have that device around you when you want to control the lights. You can usually schedule and do other things, which would kind of replace the daylight sensor I put outside. Keep in mind that if you're using color, you're going to have to use 4 or 5 wires possibly to run from your controller to the lights. If you're using pixel color, which is digital lights, then you need 3 wires, and you're going to have to accommodate and account for that in your planning. Hopefully this video was helpful to you. I have other videos on some things we converted. I recently converted a bookshelf into an entertainment center. I also have some review videos on some of the components I used here, like the dimmer. And I also have a nice one on wire management to help you in your LED stalls to conceal the wires.